In this video, I'm going to go over how you can solve a two-step equation. When we're solving two-step equations, you kind of want to think about if x were a number, what operation would I be doing first? And what operation would I be doing second? And then to solve and get x by itself, we want to kind of go backwards and undo each of those operations. So if x were any number, we would multiply it by this 3 first. So we would have multiplication first, and then we would add this 7 on. So we would have addition next. So now we kind of want to undo each of those. To undo the addition, we would subtract. And to undo the multiplication, we would divide. So that's kind of how we're going to go about getting the x by itself. We want to subtract first and then divide. So since we were adding that 7, we want to undo that with that subtraction we were talking about. So we're going to subtract the 7 from both sides. We want to simplify each side. So the 3x plus 7 minus 7, that's just going to get us 3x. And then 19 minus 7, that'll get us 12. Now we want to do that division I was talking about. We're going to divide both sides by 3 because 3 and x are being multiplied together, and division undoes that multiplication. So now we can go ahead and simplify each side. The 3's are going to cancel, leaving us with just x, and 12 divided by 3 will get us 4. Since the variable is by itself, that is our solution. X should be equal to 4. But let's check that. To do that, we want to rewrite the equation. And then we want to go ahead and plug in 4 for x, because that's what we found that 4 was equal, or that x was equal to. In this case, we do want to put that 4 in parentheses because these are really being multiplied together. So we don't want to think that the 3 and 4 are 34. We want to make sure it's 3 times 4. Now we can go ahead and use our order of operations to solve. And we actually already wrote down those order of operations up top in the very beginning of this problem. So we can multiply the 3 and 4 together to get 12, carry everything else down. Then we can add 12 plus 7 and we will get 19. And since 19 is equal to 19, that means our solution of x is equal to 4 is correct. Moving on to the second example, we want to kind of go about the same process. We want to identify if the variable was a number, what order of operations would we be using, and how do we undo each of those? Since b is our variable, we're dividing b by 3. Division is the first operation that is applied to b. Then we're subtracting that 2. So we have division, then subtraction. To undo subtraction, we would add. And to undo division, we would multiply, because these are using those inverse operations. Now what we can do is go ahead and start solving the problem. So again, we want to do that addition first, because we want to undo this minus 2. So we're going to add 2 to both sides. Then we can go ahead and simplify. b over 3 minus 2 plus 2. The minus 2 and plus 2 are going to cancel, leaving with b over 3. And then 6 plus 2, that'll get us 8. Then we're going to go ahead and do that multiplication we talked about. That's going to undo this division. So we're going to multiply both sides by 3. On the left-hand side, those 3's are going to cancel out, leaving b by itself. And then 8 times 3 is going to get us 24. Since our variable is by itself, we have completed solving the equation. And again, we can always go ahead and check to make sure we did it correctly. So when we do that, we want to rewrite the original equation and then go ahead and plug 24, because that's what we found b was equal to, right in for b. Now we can go ahead and use the order of operations that we identified in the beginning to go ahead and solve and simplify this equation here. So we want to do that division first. So 24 divided by 3, that gets us 8, minus 2 equals 6, and 8 minus 2 is 6. And since 6 is equal to 6, we know that 24 is the correct answer for this equation. To briefly sum up solving a two-step equation, you always want to think about what operations are being applied to the variable and how can we go ahead and undo each of those operations. And that's how you solve a two-step equation.